Good evening, everyone. So, today we will start with learning low level design. We'll start with design patterns. So, basically, one second. Mm, Weird. Hmm. So, we'll be learning design patterns. Okay. So, what are design patterns? What are design patterns? Okay. So, design patterns are solutions to common problems that are usually faced in uh, software engineering and have been solved by experts. So, for example, what I mean to say is there were like in earlier days of software, we only had OOPs, right? So, object oriented principles. That basically includes your abstraction, right? And encapsulation, polymorphism, morphism, inheritance, right? So these are the basic inheritance uh, object oriented principles that we always had from day one. Like eventually after Java we always had OOPs, right? So like this is kind of a prerequisite for the design patterns as well, because once we understand what OOPs is and we get good at OOPs, uh, the next step of that evolution is design patterns. So again, what are design patterns? So design patterns are common solutions to the general problems faced in software engineering. For example, let's say I have to design a large scale application that I know will be maintained for for decades. So the design that design should be extensible, right? The code and all that things we do should be extensible, and even if in future if the developer changes or a new team comes up, they can basically use a shared vocabulary to work on that, right? So uh, like we will be those like these are basically the design patterns. So if we say it's a common vocabulary. So if I say that if someone has implemented certain thing and instead of going in detail, they can just use a one word that uh, that would be like very fast to communicate as well, right? So example of this would be, let's say that if you go into a coffee shop, right, and the coffee maker and you share a common vocabulary, you can basically say I will take the usual, right? So just the word usual and they will understand what you want, right? Because you and they have a common vocabulary. uh, while someone who when a new person comes in, they have to mention the whole order that I want a, let's say, creamed latte with chocolate syrup, and it should be cold and all that. So basically, yeah, it gives you a common vocabulary or a lingo. Let's say it's a lingo. Mm. Like you must have heard senior engineers saying, let's do that via a strategy pattern or a observer pattern. Uh, like that, those are lingo in software engineering, and these lingos like are common across industries, not just software. So yeah, that's pretty much what the design patterns are. Like we will come to the example later also. Now like we have OOPs, like these are the principles of OOPs: abstraction, encapsulation, polymorphism, inheritance. Let's start with the principles of design patterns. So I can just say principles, and so we will be like, for the basics we will look at these principles: encapsulate what varies, favor composition over inheritance, and program to interface, not implementation. Okay, we will go over them one by one. Okay, so yeah, so we will go over them one by one. So first principle is encapsulate what varies. Let's understand what problem this one is solving, right? So one second. Just give me a moment. Weird. One second, just give me a moment. Okay, now my screen should be visible. Okay, so let's take an example of, let's say we have encapsulate what varies. So let's say that I have a, I'm trying to get a problem here. So let's say that I have a class car, right? So we will have a car. So we will have an abstract class car, right? So it can, let's say, contain okay, it's in Java, right? Let's move on Java, no issue. So it can have, let's say, a speed. So it can have speed, right? And it can have speed, it can have, let's say, gears, it can make us horn, right? It can have an engine, right? So like these all it can have. So what we want is that we need to, let's say, design 100 cars, right? And we can assume it's a single factory, and we all the like factories are all the, what we say, all the manufacturers give order to this single factory and they design the car. So okay, so we can have a Hyundai car, let's say, right? So Hyundai car that extends car. So this is basically your inheritance. So Hyundai car extends car. Okay, it will have some speed, let's say return 120. It will have some gears, let's say return 6. It will have a horn, let's say return beep beep, right? And it will have a engine, let's say return V12 maybe. Okay, so this all it would have, right? It will have. Another would be, let's say, a Maruti car. So car, it would be run at speed at, let's say, 80. Gear would be 5. Horn would be honk honk. And engine would be, let's say, S. Any engine, right? And E1, let's say. Okay. So similarly, let's say that we have 100 such cars, right? And like everything is working good, all the companies are happy that the software is working great, but suddenly after some years or maybe like in next iteration, we come with everyone comes with a requirement that let's say that they want a new car, right? And it will be used for testing, so it would be a test car. So it would be a test car, extends car. So it will be used for the testing purposes. Okay, so this will be a test car, and they want that like it should have some, let's say, like I implemented the requirement as a new developer. I have a test car. I say that okay, it's a test car, it will go at 50, gears would be 5, it won't have any horn, and engine would be standard, right? So I just they want that okay, a test car should also let's say uh, have passenger that are dummy. So abstract int, I will just add passengers, right? And everyone would implement that. Everyone would implement that. So a test car would have 2 passenger, 1 passenger. Let's say no, Maruti car would have 4 passenger. Hyundai also would have 4 passengers. But now comes a problem. So if I had 100 such cars, I added passengers, I had to add it into each one of like those, right? And they want that I also, let's say, add a okay, give me a moment, someone is at my door. I will be back in 2 minutes. Okay, hi. So I'm back. So yeah, where were we? We were having these cars. Yeah. So let's say that a new requirement comes in that the dummy car would have a new engine. Okay, so it would test car would have a different kind of engine. So it would have a standard engine, right? So I did that. But what that would ruin is, let me just think of something. Or let's say that it does not make a sound. Okay, so I don't know about any other car. Okay, so a very vague example, but let's say that I don't know any about all these 100 cars, and it says that it won't make any sound. So I will just turn null here. Okay. Uh, or let's say that it would have a new gear system, right? So it would have a new gear system. So like basically any change comes in. Okay, I think we can take a better example out of it. Because car, these are very standard properties of car. Any property that is exclusive to the test car. Okay, yeah. Let's say that we have to add some stickers to the test car. Like global NCAP requires some stickers to be added to the test car. So what I will do, I will just say I will add some stickers, string stickers, right? But now I see a problem is that every other car must extend some stickers, and if there are 100 cars, 100 cars would extend the stickers. Okay, so now how will we handle this, right? So in terms of OOP, this is a like a good design good principle. We extended the common properties of the car, and now we got a new requirement that a test car must have a sticker, right? So here comes the first principle, encapsulate what varies. So now obviously if I add a sticker here, I would have to add it to every other car, but that's not how we will work. What we will do, like we will basically difference out the property. We can just say abstract, or we can say, yeah, abstract and stickers, string stickers, and yeah. So basically what will happen is, maybe static, okay, we are not focusing on that. Anyways, so we have this, right? Let's make it null. Okay. So now what happens is we encapsulated what varies. So it needed a sticker, we added sticker here, and we created a sticker, right? And it only applies to the test car, not any other car. Okay. So this is our first principle, encapsulate what varies. Coming to the next principle, which is favor composition over inheritance. So what is composition, right? Composition is basically uh what how will we define it? Basically composition is combined objects, right? So it's it's basically combined objects. Combined objects. uh, when we say that what something is composed of, we usually mean uh, what all objects it contains. Okay, so right now what we implemented was basically uh, a simple, let's say, a string that lives in the abstract class, and we change its value, right? What composition say, like, instead of this, what we should do is basically have another sticker object, like class sticker, right? And this we have what will it have? String stickers. Test logo. So what it says, that instead of inheriting all this property, we should must have a composition, right? So basically a car class as a class must be composed of various different objects. Right, so right now every other car is basically inheriting these properties, but it should like generate these properties on its like, if I say I get a Hyundai car, then it should generate the engine, it should generate a horn, it should generate the passenger seating and all that. Right now it is like inheriting everything. So when I say that the car must generate a sticker, what I really mean is, in the constructor I basically pass sticker. Okay, my bad. I should pass a sticker, right? And by default, oh my bad. One second. In Java, we do a constructor like this. Car sticker, right? This should be private, and this should be this dot sticker to sticker. Yeah. So when I construct the car object, it should now contain the sticker. And another, let's say we have a car object that is like this, right? So whichever car needs a sticker, let's say that I create a test car. I create a test car here. So it's a test, let's say car which is a test car. And now test car would automatically say that a method call was expected. A test car would say that it needs a, one second. Hmm. Say test car needs a sticker. Yeah, so we can basically enforce the test car to have a sticker. So now the test car must provide a sticker, right? Test. While my another car does not need a sticker. Okay, so now I have both the cars we can like constructed, and my test car have a sticker and my Hyundai car does not. So I don't have to inherit all the properties. If I would have added sticker here, I would have to make, let's say if there are 100 cars, I would have to change every car, right? But now I can easily extend this. So this is basically what we mean by when we say favor composition over inheritance. Now let's focus on the come to the third principle. Yeah. So the third principle, what it says program to interface, not implementation. Right. So right now we have concrete implementations. If you see, like, so right now we have concrete implementations. We have concrete implementation that a sticker must be a string. That's like a concrete implementation of it. What we want is basically we have a sticker interface, or let's not go there. Let's say we have a various engine types, right? Now if I create, ideally the car should be created of, let's say, car of, should be created of a engine. Car must have gears, gears and So here must have this dot. Gear. Okay, and this dot is equal to this dot. Yeah, and this car should also contain it. So like these all are principles of favor composition over inheritance. So we have seen a real time example. If you don't favor composition over inheritance, then we have to like put a bunch of stuff. If it would have been like this from day one or from the start, we never needed to do this. Okay. Hmm. Okay, now I can basically say that test car must contain an engine, so I have to provide it an engine standard, and let's say it contains gear, so it could have 4 gears. Now this is my composition over inheritance thing, right? I don't. Okay, 1 second. Right, and I have to, when I create a Hyundai car, I have to provide an engine. Let's say we give it a V12, and we must provide a gear for. Right. So like if this is my composition over inheritance, also it kind of represents uh, that it is programmed for interface, not an implementation. It's just not. It's just that our the interface is not very clearly visible. So I can easily swap out my engine. Like I can have a Hyundai car with a standard engine. So like that, I can swap it out in the real time. But let's take an example here, right? So we will look at it from an interface perspective. So let's say that I have let's say interface engine, right? It have, let's say, a property, not int, let's say test type, not my bad, it should be type, right? That's it. Or let's say string of type. Okay, so it would be a interface engine and it would be of type, sorry, it would contain a type. Okay, so like engine can be of different types. So let's say we have two engines. What engine we give to Maruti car? We never give it engine, huh? No problem. So we have two engines. Let's say uh, class standard engine, which extends, or we would say implements engine, right? Methods type. So it would be return standard, and we have a V12 engine. It will return a V12. Instead of a string, we will now take an engine. And I can basically swap out an engine at any time. So I can give a test car a, let's say, a V12 engine if I want. Right? Right now I again a standard engine. Similarly, a Hyundai car could contain a V12 engine, or it can contain a new it's a standard engine. Okay. So now if I say test car dot get engine system dot and Hyundai 2 Hyundai dot get engine, then if I run it, okay, my bad. So okay, set print ln, my bad again. So yeah, see, test car contains a standard engine and Hyundai contains a V12 engine. So yeah, that's pretty much all the three principles here. Basically encapsulate what varies. We encapsulated the engine, we encapsulated the stickers, right? Not in exactly encapsulate, but yeah, we separated out the stickers and favor composition over inheritance. So now our car is being composed rather than being forced to implement things, right? And program to interface, not an implementation. So yeah, so we have engines and which are like interface, and these are not concrete implementations inside a class. So Now let's test our whole principle. Let's say like I'm making it on a runtime. So let's say that a requirement comes in for a dummy car. So dummy car is nothing but a, let's say, a model to display in showrooms and all. So now we can easily make a dummy car. So we will just say class dummy car, which extends car, right, and it implements all these methods. So a speed would be 0, obviously horn null, yeah, passengers also would be 0, right. It won't contain any stickers. Now what I want is basically I need a new car, dummy car. They say that make a new car. I have not touched any other code, right? Nothing gets changed, and they want that why we don't want to like waste an engine on a new car. So we'll just say dummy car, and what all at once it wants a engine. I will say no engine, right? Because why would I give an engine to it? And gear, 0 gears, so it won't have any gears. Now easily we can incorporate a new requirement into our like this uh, let's say program, right. Earlier we were struggling to implement a test car. Now we can easily include a dummy car. So like this is what design patterns is all about. Slowly and steadily as I move forward, we will be looking at different type of design patterns. And yeah, that concludes everything. Thank you.